Alright, looking at this question, it's a general expression for differentiating of polynomials. So, to differentiate x power n, it's a general expression for it. So we have dy over the x equals this n here, we multiply one invisible one here, okay? So we have n multiply 1, which is n, we write the x, and we write n minus 1. This is a general expression for differentiation and also for polynomials. Alright, so we are going to look at some example. Let's take this as an example. Let's say we have y equal x power 2, for example. Okay, or we can also start from x, just ordinary x. That is, we differentiate y with respect to x, and we have dy over dx equal, because there is an invisible power of 1 here, and this one stands for n, so we say 1 multiply 1, which gives us 1, and we have x power 1 minus 1, okay, and we have 1x power 0, and we know according to indices anything power 0 is equals to 1. So we have 1 multiply 1, which equals to 1. So the differentiation of x is 1. So we are going to look at another example. Okay, we have this example, y equal x power 3. This is easy. It's the same way we did the first one. So we write dy over the x equal 3 multiply 1, which equals to 3. You write the x again, and you say 3 minus 1. Okay, so we have dy dx, which equals to 3x 3 minus 1, which is 2. dy dx. Okay, so this is the differentiation of it, and we can have another example just beside it. Y equals to x power 4 plus 2x. Let's differentiate this. 4 multiply 1, which gives us 4, and 4 minus 1, which gives us 3. Okay, and we have this also because we want to differentiate with respect to power 1. The x, so 1 multiply 2, which gives us 2, and we write the x 1 minus 1, which equals to 0. And we know that when x is power 0, it gives us 1. So 1 multiply 2, which gives us 2. So we have final answer 4x to power 3 plus 2. Okay, we'll do more example. This is a great example of polynomial. So we can differentiate this, which is quite easy. dy dx. 3 multiply 1, which equals to 3. X and 3 minus 1, which gives us to 2. Plus 2 multiply 1, which gives us 2. X 2 minus 1 will give us 1. Plus 1 multiply 4, which is 4. 1 minus 1, which is 0. And x power 0 is 1. And the differentiation of 5 is 0. Why is it 0? Because it does not have the value of x. There is no x. So in differentiation, we differentiate to the respect of x. And since 5 does not have x, we can't differentiate it because it does not have x. So we consider it to be 0. So we look at another example. Alright, in some polynomials, for us to differentiate this kind of question, it's not kind of easy to differentiate the square root of x. So what we need to do is to change this square root to become an index. So square root can be written as 1 over 2, x power 1 over 2. And how do we differentiate this? We say 1 over 2 multiply the same one here, which equals to 1 over 2x, and 1 over 2 minus 1. So the given answer gives us 1 over 2 x negative 1 over 2. If you press the calculator, this is what you're going to get. Half multiply 1, which is half x, 1 over 2 minus 1, which is negative 1 over 2. With this, you can always write your dy dx. Look at this beautiful and handsome question. It's easy, but before you can differentiate this, you need to change this fraction to become something you can be easy to differentiate. Okay, so we have first of all, I'm going to change this to become 2x power negative 1. You know, whenever we have x down, we can bring it up to become power of negative 1. Okay, so plus we can also change this to become x power 1 over 3 because it is cube root of x, not square root, now cube root. So this one becomes 1 over 3. So this situation we can now differentiate the y, the x. So if I say negative 1 multiply 2 give me negative 2x, negative 1 minus 1 gives me negative 2. You remember that we are going to always subtract 1 from the power in differentiation. Don't forget that. Plus 1 over 3 multiply 1, which is 1 over 3 x, 1 over 3 minus 1. Okay, 1 over 3 minus 1. So we're going to do this also. And how do we solve 1 over 3? You can just put 1 over here and say the cross multiply, 1 multiply 1 and this, which gives us 1 minus 3 over 3, which gives us negative 2 over 3. Okay, how do I got this? 1 multiply 1, which is 1, 1 multiply 3, 3 over 3 multiply 1, 3. So 1 minus 3 divide 3, which gives us negative 2, power of negative 2 over 3. This can be changed to become negative 2 over x power 2. You remember how we changed this, right? You remember we changed this from x, which is down, the power 1 here is this one here. So we change it up, become negative 1. And this one has negative 2 now. So when it comes down, because this negative simply means 1 over. So x power 2 here plus 1 over 3. This x also, because it has a negative of this, we can also change it. So if it has to come like this, so we can write 1 over 3 cube root of x whole power 2. Okay, so we can just write this properly. 1 over 3, this is the 1 over 3. This x here is this, I told you this negative means 1 over. So this drops down, which is x 2 over 3. Okay, power 2 over 3. Let me write this very well. So it becomes x power 2 over 3. Okay, and I change this 2 over 3 back to this way. That's where we are coming from. Root 3, which is the 3 down, which is the cube root. The same one also here, the cube root 3 also become cube root of 3. X and this 2 up here is the power 2. Okay, you can try this at home and send your answers to the comment section. You can message me on my website, okay, ranset.com. Thank you so much for listening. Thank you so much.